I'm not a scientist, I'm an engineer, so I like to pull things apart and understand how they work and what the limitations of things are. So in any situations, I like to define terms. So here's a quote from DeepMind. It's their mission statement, which is Google DeepMind. Solve intelligence and use it to solve everything else. The problem with that is no one's able to define intelligence. I'm not going to offer a definition. You can go to Google and get any infinite number of definitions you want. But I'll assume you know what it is, because human beings know what it is. We might not be able to describe it with words, but we know what it is, which is part of the problem of language and the human condition. We are much more fearfully and wonderfully made. So, being unable to define intelligence, what about artificial? This is an artificial picture. This is quite a famous image from Frank Hurley. When is it? 1917. Picture of the First World War. Except it's one of the really early fake pictures. It's really a composite of negatives, which is quite an advanced technique for 1917. The original picture was just the men coming out of a field. And, of course, he's added in the explosions and the planes and everything else. It's quite artificial. And we use the word artificial in one sense, like this. It's an imitation. It helps us to imagine different things. It's not real, but it helps us to imagine. So there's artificial in that sense. And there's artificial in another sense. For example, we could make artificial petrol. We can go to the lab and mix the chemicals up and create petrol using chemical means rather than digging it out of the ground. And we would call that artificial petrol because we made it in the lab. But it's the same thing. It's exactly the same. You can put it in your car and run away. So you've got those two senses of artificial. I use the word little a AI and big A AI. So little a AI is intelligence which is a lookalike for human intelligence, whereas big A AI is just simply the attempt to actually remake humanity's intelligence inside some sort of machine. Some people call that soft and hard AI. Lots of ways of describing it. If you ask ChatGPT about creative AI, which is all the go at the moment, it says this: creative AI tools can be seen as sophisticated plagiarism software, as they do not produce genuinely original content, but just emulate and modify existing works by artists to circumvent copyright laws. Which is true, that's all it does. So, I'm going to take an engineer's perspective and look at what we can do with what is in hand at the moment. So firstly, let's look at the limitations that we have with just the hardware. People aren't aware that digital algorithmic machines, basically computers, currently hit a peak. They're not going to get any faster, and there seems no way of increasing their performance. That's been known for about 10 years, but no one advertises that because it's not good business. But that's where we're stuck. And yes, we're making lots of little things, but the problems of heat and the quantum problems that are starting to emerge because they're so small, there seems to be no ways around them. Digital computers, let me use that word. Computers are stuck in the von Neumann architecture, nice little single lane funnel. That's not changing. All the big neural nets, all simulations done on von Neumann architecture machines. And at this stage, there seems to be no replacement. Yes, there's lots of experiments and research work, but nothing that will come to fruition in the near future, in my view. And of course, we suddenly realise that algorithms themselves are limited. So algorithms can only do so much. For example, if I were to give you 100 students and say 20 subjects that they're studying, and I give you a slot of 30 spots in which to move all those bits about so that everyone gets to do what they want to, it would take you more than several universe lifetimes to resolve that with an algorithm. That's algorithms. They're limited. We don't understand them. So, I want to look at a number of objections and limitations that people have spoken about in regard to hard AI. So we're talking here about making machines which actually do think. So first objection comes from an old guy, Dreyfus. He published in 1977, and then again his book in 1992, What Computers Can't Do. And that's a pretty much a summary of what he's said. Brain's not digital, brain doesn't follow a set of rules, no such thing. Knowledge cannot be formalised outside of humanity. Now that's debatable, but that's a philosophical discussion, and language does not communicate facts, which is an interesting angle on language, and I think it's true. The first two are now widely acknowledged. So people have said, well, yeah, that's the first two are right. This is way back in 77. The other two, well, there's some debate, but people just tend to ignore it and go on and do what they want to. More interest is John Searle. He's a famous character. He's famous for his Chinese room proposition, his paradox, the Chinese paradox. So you have a room, you don't know what's inside, you see the little window, as it's the door with the little slot where you can pass messages. And there's Chinese speakers on the outside, and they're passing in messages. And the guy inside, or the thing inside, which could be a computer, it could be a person, is passing back responses to the messages that the Chinese are sending in. And the Chinese are concluding, wow, he's an intelligent Chinese speaker. But all the guy inside is doing is looking up this huge book, as you can see there, which has all the instructions as to how to interpret it all and how to respond, which is what a computer would do. So, you would never say that the guy understood Chinese, so why would you say a computer understands Chinese? The upshot of that is Pat Hayes is a professor emeritus in America. The field of cognitive science ought to be redefined as the ongoing research program is showing Searle's Chinese room argument to be false. And no one has. They just ignore it. More interesting, if you want to go down into mathematics, this is interesting. Roger Penrose, back in the late 70s, started writing, and he's still writing actually. He's in his 90s now, on the mind. So Roger Penrose, how many people know Roger Penrose? You should. Yes, all the mathematicians, yeah. I mean, he's the sort of brains behind Stephen Hawking. I mean, Stephen Hawking was studying under him, and they worked together on the black hole work that Stephen Hawking became famous for. And he's won a Nobel Prize and so on. So he's someone to take seriously. So in his Emperor's New Mind, he makes the argument that we have this problem with Gödel's incompleteness. That's the idea that in a numbering system, you can't have both a complete system and a consistent system. You can only have one or the other. Now, that's very complicated. But Penrose points out that humans can. There are human beings that can work around that. Therefore, he concludes that thinking is not even algorithmic, cannot be. Okay, yes, some people have objected, but the objections seem pretty thin. He seems to be on good ground. And there's some researchers recently from, I think, Israel, a group of Israelis, who were looking at the problem of pattern recognition and also concluded pretty much the same thing. Fascinating. You can go and read his books, fascinating books to read. His conclusion is that the brain is still mechanical, it just works on a quantum basis. And he proposes various ideas about how the brain might be a quantum machine. So, yes, skipping. Okay. Polanyi. well known. But I suppose Polanyi's best known for his paradox. We know more than we can tell. And to demonstrate that, you've seen the rugby pictures. This is a famous picture recently. This is the new star of the Australian Wallabies. They still lose anyhow. But what is he doing? If we could somehow or other have these, all these researchers and scientists come and look at and watch what he does and decompose it all. But by the way, he's throwing a ball without seeing. He knows there's a winger out on the edge there, and he just flicks it out the back somehow or other, right into the hands of this winger who goes around. And we win this match, actually, because of that pass. How does that work? How does that work? Yes, you can decompose it and say, yes, we could make a machine like that. But is that what's going on? There's no proof that it is. It's mysterious. Here's Michael Polanyi's quote about, he uses the term tacit knowledge. Okay, tacit knowledge is knowledge that we know, but we have no words for. Tacit knowledge can be possessed by itself. Explicit knowledge must rely on being tacitly understood and applied. Hence, all knowledge is either tacit or rooted in tacit knowledge. The idea of a wholly explicit knowledge, one we can sit and write down, put into a computer, that idea is wholly unthinkable. That's a very interesting philosophical position. The idea of having knowledge that can just take outside of humans and sit over there may not be a reality. Now that's speaking against a whole line of Western thinking, which is what Polanyi was famous for. Or David Bentley Hart, who, that's a summary of his work. So functionalism is the idea that you have brain neurons that creates thinking, semantic thought, which creates consciousness and creates the very magical thing of intent. And Bentley Hart just says, that's nonsense. I mean, there's nothing that holds that together. And he goes in his books to describe why that's the case. Instead, he advocates an irreducible psyche, that people, mind, life, language is not different things. It's all the same thing. It's all wrapped up together and impossible to separate out. So on that basis, the big AI vision is pretty much a train wreck. Okay, everyone ignores all the objections, which are quite deep and profound, and they just keep on going because lots of advertisement means you get lots of investment and you can go and do more of the stuff you want to do. And then that's why we have AI winters. That's a historical term for referring to the times when AI has been given lots of money to do things and they haven't been able to do anything and the money runs out. And we may well go through that in this current stage as the money will, I think, run out eventually when things really don't happen. So, let's have a look. In the current world, we have two forms of AI, of soft AI. The generative stuff, which is your large language models, and you've got the predictive stuff, all quite different. So, generative AI is flooding the market at the moment with a lot of attention, but I find its offerings dubious, poor quality, interesting and surprising in many ways, but it's not creative in any way. However, predictive AI is a different game. It's, predictive AI is these things here. The ability to integrate knowledge sources from all over the place, from people, replicating human behaviour by just watching people and then repeating it, and discovering patterns in large data sets. For example, they found, this is data mining, they found that insurance. Did you know if you live on the north side of a street, you have a lower insurance claim rate? It happens all the time. Than if you live on the south side. I suppose that might be important to some people. I don't think it makes much difference. Predictive AI is popping up everywhere, and it's hidden in the background. Generative AI is in your face all the time, seemingly very useful. It's not. Whereas predictive AI is most useful. It's popping up all over the place in customer relationship, supply chain management. And, well, let's take a real example. Australia is going through an energy revolution, transition. And if you read the ISP, you'll find some surprising things most people haven't written there. So when the sun goes down and we need to have some storage, people aren't aware that the plan is for every house, most households in Australia, to have 2 batteries on the side of their house, plus a solar panel system on their roof. And when the lights go out, when the sun goes down, the government's going to come after your solar panels. That's the plan. Go and read it, which is fascinating. How are they going to make people... of course, a system like this in the current value, about $40,000. I'm not sure how the government's going to convince people to spend $40,000 if there's not money coming back. Anyhow, the point I'm making is that we currently have a system which runs off about 15 separate models, trying to balance demand and supply and the various things that flow out of that. Introducing renewables is going to basically make that, and already it is recognised as the most complex system in the Southern Hemisphere, this East Coast to Australia electricity network. Add renewables in and it's going to become probably an order of magnitude and possibly 2 orders of magnitude more complex. And you know what? I'm pretty confident that people will not be able to manage it. It's going to be impossible to manage all the comings and goings. But AI could. They could train AI to be able to manage it. So there's been a little bit of talk about it, but there needs to be a lot more talk about it, because the only way that we're going to be able to manage what's being proposed, and it's happening, it's not going to stop, is to actually train machines to behave like people. Okay, not be people. The big decisions will be made by people, but have machines that will behave like people and say, oh, right, this and this is happening, and all these things in parallel are happening. What do? This is how people would have behaved in that situation, and try and merge it all together. So, a couple of slides to finish off with. Do you know people have seen that movie? I, Robot? Yeah, it's fascinating. Yes, my American friends seen it. You like all the robots being blown up. Yeah, but it's 2 perspectives. Here's Will Smith. He hates robots, and he hates robots because of his own life situation. A robot rescued him. He was in a car accident, and 2 cars were thrown into the river, and they were all drowning. And the robot comes in and has time to rescue one. And the robot chooses him because he's the most likely, according to the algorithm. And there's a young girl just in the other car, and he's watching her just fade away as she drowns. And the robot rescues him. And he's yelling out at the robot, forget about the rules, save her. Even if I die, even if we both die, make a chance to save the girl. And that's a human response. Absolutely deep human response that you're not going to get out of algorithms. And he hates robots because of that. On the other hand, who's seen this one? This is a 1957 movie. No one's seen this one? This is Desk Set with Spencer Tracy and Catherine Hepburn, sorry. Oh, fun movie. And it's really quite pertinent for the period we've lived through, with computers taking over. And the whole thing is that they fall in love with each other anyhow. He's the machine guy and she's the woman with the human brain who knows everything. And the machine's going to replace. In the end, it's reconciled because the 2 come together and realise that actually she doesn't know everything and can be put in the computer, and she can use the computer to do her job a lot better. It's a very simple message. It was a fun movie as you watch the Tracy and Hepburn, always brilliant as they engage with each other. two responses, idealistic or just the very practical. I'm very practical. I can see this happening. I can see our electricity network being controlled by computers because that's the only thing that can happen to make it work. I'll finish off there because hopefully I've started a conversation because, very few people look at the practicalities. They just see all the hype.
Thank you, Mark. That's great. I think we can give him a bit of a clap for that. Questions. Now, I've been told you have to use the microphone because it's all hooked up to the recordings. So, just talk into it.
Yeah, okay. Thanks, Mark. Just before I ask my question, I was actually a slated speaker here at his class. I had to withdraw my presentations. My plate filled up in the last month, so I'm going to kind of vicariously offer some ideas through you. In terms of artificial intelligence, do you agree with the idea that the phenomenon of mind, it's not about computation or processing bits, but it's about consuming and creating meaning? Therefore, would mind be continuous or equivalent with life or living being? Is that an idea that you would agree with, that there's something about life which entails a phenomenon of mind, and if something isn't alive, it's not minded?
Right. If you were to go to Google and say, look, if you could do, what's your real goal in capturing all of this data of people that you're capturing, as they buy things and do things on the internet? They'll tell you intent. They want to know what the intent is. But what is intent? It's a very human condition. That's how I'd answer that.
So going back to your quote from ChatGPT,
yes,
about what it does, which is that it's just a big plagiarism machine. I was just thinking, in terms of human beings, undergraduates are big plagiarism machines who don't have any original ideas of their own. They simply copy what the professor says and regurgitate it. What is it that turns an undergraduate student who's using that method, what is it that turns them into a creative human being coming up with original ideas? Is that something a computer could emulate?
I remember my manager coming down, racing up to me and saying, we've got all the graduates. So my company would take on 20 graduates each year. And they had the short list of 80, I think. 80 graduates. By the way, 78 were men, 2 women. Anyhow, that's another matter. You're going to have to go and talk with them. And because they bring them in and they talk with real people who actually do real work. And I saw them all there, and some of them they looked like they had brains like this. They looked so clever. And I went up to the HR people who were going to have to make that call. And I said, how are you going to decide which ones are going to get the listings? Well, we have a process. And I said, I got a better one. Okay? Get a couple of buses, put them all on there, take them up to Oberon and give them $5 each and say the first ones back are the ones that win. And it sounds strange, but it's about resilience and ability to sort of stare down anxiety and your inability to face up to stuff that's new. So, I've got a lot of problems with education because it has generated people who just turn stuff over. I'm just thinking of a relative, I shouldn't say this, who came to this university and started to do some stuff, and he was literally thrown out because he crossed the line of some pet project, and it's sad. So yes, I've got a lot of problems. It's with the way we educate our people. Yes, we should just put more people on buses and saying, go and explore the world and experience it and then come back and make sense of it all. And of course, we make sense of it through the scriptures. We tend to think we take the scriptures and that's going to tell us, all the things we have to do in order to be good people. And I think that's the wrong way of looking at it. Instead, we should take the scriptures with us as we live. And as we live, we'd say, wow, this doesn't make sense. And the scriptures enlighten us as we go. Any question?
Hello. Sorry, this question, I tend to think as I speak, so sorry if I ramble, but just thinking how so much of how we understand the limitations and possibilities of AI turns on what we consider to be human creativity. And I know there's lots of definitions of creativity out there, and the one that scholars often turn to is the idea of creativity as like innovation and creating things that are adapted to purpose. And I'm thinking that we have that gives us a certain very technology-driven idea of creativity. But AI, I'm just wondering what your definition of creativity is and whether you think that AI can be creative in that way, if that makes sense. Yeah.
My answer to that is that only people can be creative. I got a lot to do with innovation. And early on with innovation, people had programs. So they would have the innovation program and they'd have all these education things lined up and they're going to tell everyone how you can be innovative. Problem is none of that worked. So the things we did, for example, is that we would, yes, I remember very well. We had a week where each afternoon work would cease and on the whole floor, and we'd turn the whole floor into a putt-putt golf course. Okay? And everyone played together. You'd be surprised what comes out of that. The conversations, and so the innovation comes out of people coming from very different points of view, from different areas, sort of conversing and meeting, and then being able to then see things through them differently. So that's where innovation comes from. It's the engagement of people. Machines can't have that unless you can say machine engages with machine. I don't think that makes any sense. But, innovation is really deeply rooted in humanity. The Imago Dei is, we are meant to work together. Sorry, that's not I'm sort of not giving a straight answer, but that's my perspective.